Alright, welcome to the Learning Target number 6 and 7 video, chapter 1. Okay, this is where we're going to set a lot of, this is a hard, I don't want to say it's the hardest, one of the harder units, but this GCF and LCM stuff that we're going to be talking about is tricky to a lot of students. So make sure you really pay attention, and you really need to work hard in this unit because this unit really sets the basis for the rest of the year in a lot of ways. So we're going to cover just this one and this one in this unit, and then the next, or in this video I mean, and then the next video will be 8, and then the next video will be 9, and then so on. So let's go ahead and flip to page 12 in your notes. Okay, so get there. Should say common factors and multiples at the top. Again, I apologize for my voice. I'm really not feeling well. Sorry if I'm annoying sounding. I think I am. But regardless, okay. So here's your learning targets for this unit, for this video. Find the common factors of two whole numbers less than or equal to 100. Now we talked about factors in the last unit. Remember, I'll go ahead and remind you. So if we took the number 6, I know that I can have factors of 1 times 6. I also know that I got factors of 2 times 3. Okay, those are all factors. 1, 6, 2, and 3. Those are all factors. Okay, what this is going to be is finding common factors. So in other words, you have two different numbers. So I give you 6 and I give you 8. And you got to then tell me, what do they have in common? What factors do they have the same? So as I said, 1, 2, 3, and 6. Then this would be 1, 2, 4, and 8, where I'm getting that. 1 times 8 is 8. 2 times 4 is 8. What do they have in common? Well, they have 2's in common. They have 1's in common. They don't have 3's or 4's. They don't have 6 or 8's, but they have 1 and 2. So what are the common factors here? They have the common factor 1. They have the common factor 2. Okay? That's all Learning Target 6 is. It's just identifying common factors. Whereas Learning Target 7, we're going to talk about finding the greatest common factor. So the greatest common factor over here would have been 2. Okay, they're just the biggest common factor that two numbers share. Okay, so that's all this is. Okay, let's go down and look at this first example. You can just look at it. You don't have to write anything. All right. So you can see they already did the work for you. So just check it out. They gave you two numbers. They said find the common factors. In other words, factors that they share or they have in common between the numbers 12, so the number 12 and the number 30. That's all it's saying. And you can see they just listed out the factors. They figured out that 1 times 12 is 12, 2 times 6 is 12, 3 times 4 is 12. So they listed them right here. And you're going to hear me refer to this as the list method. Okay? The list method is just listing all the factors. Notice they put them least to greatest. Everybody write that. Least to greatest. You always have to do that. Trust me. It will benefit you. Least to greatest. Least to greatest. Okay? So they did that. They just took 1, 2, and 3, 4, 6, and 12, and they put them right there. They did the same thing for 30 right there. They just took them, put them right there. Okay? No big deal. Now what they're doing is they're identifying which ones they have in common. You can see that they have those circled. They have 1's in common. They have 2's in common. They have 3's in common, and they have 6's in common. Okay? So the common factors are 1, 2, 3, and 6. That's all they have in common. They don't have anything else in common. Okay? Let's go to the next one. Use the lists of factors on the right and the common factors of 10 and 28. So they've already done the work for you here. Okay? So it says the factors of 10, well, they are 1, and just do your best to write over top of those question marks, 2, 5, and 10. 1, 2, 5, 10. They just listed them out. Again, I went smallest to biggest. The factors of 28 are 1, 2, 4, 7, 14, and 28. Just getting it from right here. These are your factors right there. Those are your factors. And then you look at it and go, oh, well, which ones do they have in common? They have 1's in common. They have 2's. And that's it, right? They don't have 5. They don't have 4, 7. They don't have anything else in common. That's okay. but they do have the number 1 in common. They have the number 2 in common. Okay? I would like you guys to pause the video and do number 2 and number 4. Okay? So, number 2 would look like this. 16. The factors of 2. I know that 1's a factor. I know that 2's a factor because it's even. 3 is not a factor. And if you wanted to list it out the way they did too, you could. I'll do it for you right now just so that you guys can see it. So 16, I know that it'd be 1 times 16, 2 times 8, and 4 times 4. And don't forget any. You got to make sure you check them, okay? Those are your factors. Let's do 24. That's going to be 1 times 24 would work. 2 times 12 would work. 3 times 8 would work. And 4 times 6 would work. Okay? And those are all your factors there. Okay? So now let's list out the factors for 16. 1, 2, 4, 8, and 16. And then for 24, we're going to put 1, 2, 3, 4, 6, 8, 12, 24. Hopefully I'm not missing any. I think I got them. Okay. And then I start just for which ones are they the same? 1s, 2s, 4s, 8s, and that's it. So we know that these have common factors of 1, 2, 4, and 8. 1, 2, 4, and 8. Okay? Now, if you're really good at your math facts, you're probably really quick with this. If you're not very good with math facts, then it probably takes you a little longer. Okay? It's something that you need to shoot for, something to keep working on. Okay, 36. Okay, I know that I can get there by doing 1 times 36. 2 times 18, 3 times 12, 4 times 9, 6 times 6, that's it. Okay, 50, I can do, and again, if you're having trouble knowing these, if you don't know these off the top of your head like some of us do, then you're just going to need to start typing into your calculator. 36 divided by 2, see if it gives you 18. 36 divided by 3, see what it gives you. 36 divided by 4, and so on. Okay? 1 times 50. 2 times 25. 4 times 15. I'm sorry. What am I doing? That's not right. I was thinking about 60. Okay? 5 times 10. And I'm pretty sure that's it. Okay? So those are your factors. Now let's just list them out here. For 36, it's going to be 1, 2, 3, 4, and 6, and 9, 12, 18, 36. Again, I'm just listing I'm just listing the factors out. Okay? 50. It's 36. This is 50. We got 1, 2, 5, 10, 25, and 50. Okay, now let's just go and figure out which ones they have in common. They have 1 in common. They have 2. They have... Looks like that's it. Four. Yep, I think that's it. That's all they have in common. So, as you can see, even though you got all kinds of factors here, they don't have to necessarily have a bunch in common. Okay? Alright, let's go to the next page. Now, this is learning target number 7. Here, you can go ahead and write that. Probably not write in highlighter. Okay, learning target number 7. We just did 6. 6 was just identifying the common factors. Now let's identify the greatest common factor. Now there's 2 methods that I'm going to show you here. Okay, first of all, the list method. This is going to be the same as what I just showed you. Okay, now I'm not going to ever do it this way because, you know, the list method is great unless you know your math facts. And not to mention, if I give you a huge number like 756, and 812 and say find the GCF, find the greatest common factor, it's going to be hard to list out every single factor. That's hard. That's why this method right here, it's okay for smaller numbers if you're good with your math facts, but for the most part, I want you to do number 2. You can see right here that they listed out the factors. By the way, I forgot to mention this. This, you will hear me refer to greatest common factor as GCF. Okay, just understand that that's what I'm talking about, greatest common factor. Okay, now let's go down to the second method, which is what I was talking about, okay? This is the method you're going to use about 99% of the time. Okay, you are going to use this method. It's easier, trust me. Okay, so you can see they did the prime factorization for 45 and 75. This is using the prime factorization method, okay? Okay, so they did the prime factorization. Now, the only thing they did differently, I don't make you guys, I would have circled it here and then I'd have circled. We always circle prime numbers, if you'll remember from the last learning target. So when you circle them as primes, when you're doing GCF, we would write this out as 3 times 3 times 5. That's 45. And then for 75, we would do 3 times 5 times 5. And what you're looking for here is you're looking for common prime factors. Do you see anything common? Well, you should say yes. You see 3's right there. I see 5's right there. Okay? Then what you do is you take those common prime factors and you bring one down from each of that section and you do 3 times 5. Your GCF is 15. Now, if you're sitting there going, whoa, you just blew my mind, you will get this. Trust me. All my students last year were good at it by mid-year. It just takes a little bit of practice. Okay? So to recap, what you do. Now, step 1, you do the prime factorization. That was already done for you over here. You should know how to do that because we just did it last unit. Or last learning target. Okay? Then you stack your prime factorizations and you look for common factors. There you go. We have a common 3, a common 5. We multiply them together. Our GCF is 15. We could have found, and if we go back up here to where they did the list method with the exact same two numbers, 45 and 75. They had common factors of 1, 3, 5, and there was the biggest, 15. Okay? Go to the next page. Okay, here we go. Find the greatest common factor of 20 and 32. You could look through here and say, okay, they have 1's in common. They have 2's in common. They have 4's in common. Okay, do they have 5's? No. Do they have 10? No. Do they have 20? No, and obviously they don't have these then either. So what's the largest, what's the greatest, the GCF, the greatest common factor that they share? It is 4. Okay? That's using the list method. Now, as I said, this method is not the best method if you struggle with your math facts. Okay? And you don't have to worry about filling any of this out. I'm not worried about it right now. Okay? But if you go down here to method 2, using prime factorization, let's do that real quick. The first step is to do prime factorization. So let's put 20 and let's put 32. Let's do the prime factorization. What factors could I use to break this thing down into? What two numbers could be multiplied to get to 20? You could use 2 and 10. You could use 4 and 5. It doesn't matter what you use. You're going to get to the same. Then ask yourself, is either of these prime? Yes, 2 is prime. 10 can break down to 2 and 5. There you go. Now you're done. You've done your prime factorization for 20. Now let's do the same thing here. You could break this to 8 and 4. You could break it to 2 and 16. Whatever you want to do. You figure out what number you want to use. It's up to you. You're going to get the same result. I know that 4 times 8 is 32. Okay? So I'm going to use 4 and 8. However, neither 4 or 8 is prime. They're both composite numbers. So I'm going to have to go a little further here. That breaks down to 2 and 2. This breaks down to 2 and 4. And then, let me move my little toolbar there. This breaks down to 2 and 2 more. Okay? So now we have our prime factorization. For 20, it is 2 times 2 times 5. My prime factorization for 32 is 2 times 2 times 2 times 2 times 2. I hope I have. Oh, whoop. Wait, that's right. Yeah. Okay. Now again, we are now that we have our two prime factorizations, we are just looking for common factors. I see a common 2. I see another common 2. Do they have anything else in common? No, they do not. They do not have any 5s. We don't even have any numbers left up top, so therefore we just get rid of these. Those are irrelevant now. So what we're looking at is right here. Okay? So, remember, how many do we take from each section? We take 1. Okay, so 2 times 2. That came from that highlighted one right there. That came from that. The GCF for these two numbers is 4, which, if you'll remember, is what it was up here with the same two numbers using method 1, the list method. Okay? Let's do these last two. Actually, I want you to pause and do number 7 and 8, and then I'll do them. Use the GCF method. Okay, here we go. 15 and 26, I'm going to use the prime factorization method is what I meant there. Sorry about that. 15 and 27. This is where we start. This is the method I want you guys to use more than the other. This method is easier. Trust me, okay? How do I break down 15 into prime numbers? Well, I know that 3 times 5 is 15. And then I know that both 3 and 5 are both prime. Okay? 27, I know that I can break that to 3 and 9. I knew that 3 was a factor of 27. Again, if you think back to the rule I taught you, if you add the digits, 2 plus 7 is 9. 3 is a factor of 9. Okay? Then we circle 3 because it's prime. And then 9 would be just 3 and 3 there. Now we have our prime factorizations. We have 3 times 5 for 15, and we have 3 times 3 times 3 for 27. I'm looking for common factors. I see a common 3. Nothing else in common. Therefore, how many of those do I use? I only use 1. My GCF of these two numbers is simply just 3. Okay? So if they ever only have one number in common, it's that number, is the GCF. Okay? Over here, let's do the prime factorization of these. I'm going to split this. You could make this 36 could become 6 times 6, 9 times 4, 12 times 3, whatever you want to do. I'm just going to do 6 and 6. Then that breaks down to 2 times 3. Those are prime. And 2 times 3. Okay? 54 I'll do over here. And hopefully you're getting these correct because you should be checking. 6 and 9. I know that 6 times 9 is 54. You could have also broken it. You could have done 2 and 27. Okay? That's 2 times 3. Circle them. And then 3 times 3. So your prime factorization is all set. Now just go ahead and write it this, or get them stacked upon each other. So 36 is 2 times 2 times 3 times 3. So I'm just getting it from right there. Okay? And then this one is 2 times 3 times 3 times 3. Look for common factors. I see a common 2. Okay, I see a common 3 right there. I see a common 3 right there. Do they have anything else in common? No. So I look and I say, okay, I'm going to take all my commons now and I'm going to multiply them. Okay? I'm going to multiply them here. So I'm going to use 1. So that's going to be 2 times 3 times 3. And that's going to give me 18. My GCF is 18 of these two numbers. Okay? Make sense? Hopefully it does. Go to the next page. And that's actually it right there. So that's GCF. If you're confused, and you could be, I promise you by tomorrow, you will be where you need to be. I guarantee it. Okay? Good job.